This video is about some special cases when dealing with similarity. So if you look at this problem, we could actually solve this without knowing anything about the special cases. You could draw the two triangles separately and then add or subtract as necessary to get the total lengths of sides, and then write a proportion to solve for x. However, we don't have to do that. It's a property in triangles. When you have a line parallel to one of the sides, rather than drawing the triangle separately, what you can do is just compare the parts along this side. So 6 is to 9, the parts along that top side, as 3x minus 1 is to 12. We'll write that down as a proportion. So we'll say 6 is to 9 as 3x minus 1 is to 12. Now I'm not going to solve this equation so that this video doesn't get too long. You can look at some of the other videos for solving proportions, or if you're in a class where we're solving these in a calculator, you can solve it in a calculator. But the basic idea, this is just a shortcut. Again, rather than drawing the triangle separately, you can just compare the parts along the side because they're in the same proportion. So let's look at another example where there's an additional step. So again, maybe I don't feel like drawing these triangles separately, so I just want to compare the parts that are along the sides. So we might say, well, 2x minus 8, that's the part on the left. We're going to compare that to 3. And then along the other side, we're going to compare 8. Well, be careful, we don't know this part. So you might have to add or subtract. In this problem, we know the total length is 10. We know the part at the top is 8. So 10 minus 8 is 2. Then you'll write down your proportion equation. 2x minus 8 goes with 3. And then 8 goes with 2. Solve that equation, and you're done. Now, we'll look at another special case. So this looks like something really odd, but in fact, it's not. If you were to extend this line at the top and this line here, this is really just like the last example. We have one large triangle with several lines cutting through it. And the property that we're going to use is exactly the same as in the last problem. We're going to compare the parts along the sides, and they're going to be in the same proportion. So 15 goes with x plus 13, and then along the other side, 12 goes with 16. The only thing you really have to be careful about is that you go in the same order. So the 15 and the 12, the x plus 13, and the 16 have to go in that order. So if I write down my proportion, 15 goes with x plus 13, well, 12 has to go with 16. And that is exactly the equation that we'll write down. 15 goes with x plus 13, 12 goes with 16. Solve that equation, and you're done. I think we have one more. So this problem will illustrate one of the most common little mistakes that you can make when dealing with this sort of geometric diagram. The idea is the same. We're going to compare the parts. So 6 is to 8, those two parts. Then we have x plus 2. Now we've seen this trick before. We're going to have to subtract. We're going to take the entire length, which is 21, and then subtract x plus 2. If you don't include the parenthesis, you will get this wrong. You have to subtract that entire quantity. So your equation would be 6 goes with 8, x plus 2 goes with 21 minus, again, subtract the entire quantity in parenthesis, x plus 2. So what I'll see pretty often in this sort of problem, this would be incorrect. What some people will write is 21 minus x plus 2. But you can tell that these are not the same thing. When you subtract this entire quantity, you're going to end up using the distributive property. So we're going to have 21. If we were to solve this by hand, I would just solve this in a calculator in the interest of time. You're going to have 21 minus x minus 2. So please remember the parenthesis and you won't have any trouble. So that takes care of these special cases of similarity. If you're working on the homework assignment for this, there is one more set of problems using the angle bisector theorem. I already have a video on that though, so I'm not going to work those. Just go to my geometry playlist and scroll until you see angle bisector theorem, and that's how you'll do the remaining problems. Anyway, hope this helped. See you next time.